Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.5, Problem 7. This is Section 10.5, Problem number 7. It says solve for x in each of the following equations, and there are three different equations in which you need to solve for x, a, b, and c. So part A, it says log base 3 of x equals 2. It's tough to think about in its log form, so I think the way to go is convert it to the exponential form, and then you'll see what the answer is easy enough. So, in its log form, I like to say that it is Bene, B-N-E, for base number exponent. The base is 3, the number is x, and the exponent is 2. Put it in the exponential form that you're more comfortable with, more familiar with. So first you write the word, oh no, that's for log. So first you write the base. The base is 3, then you write the exponent. The exponent is 2. Then you write equals, and then you put the number. So the number in this one is the unknown. It's the x. So log base 3 of x equals 2 is the same as saying 3 to the second power equals x. Now in this form, it's very easy to see that x must be equal to 9. And then B is going to be the same type of problem. The x shows up in a different spot. B says solve for x for log base x of 8 equals 3. So this in log form, I would write Bene, B-N-E. Again, the B is for base, the N is for number, the E is for exponent. In this problem, the base is x, the number is 8, and the exponent is 3. So write it in its exponential form, which is Ben, B-E-N. The B for base, the base is x. Then next is the exponent. The exponent is 3. And then equals, and then n. The n is the number, which is 8. So in its exponential form, you have x to the third power equals 8. Well, the x must be 2. 2 to the third power is 8. Right? 2 times 2 times 2 is 8. 2 to the third power is 8. And finally, part C. C looks absolutely awful, but it's really not that bad. It says solve for x in the equation log base 3 of, in parentheses, 2 to the x minus 1, close the parentheses, equals 2. That seems bad, but it's really not at all. So, again, in its log form, I write Bene, B-N-E, for base number exponent. The base is 3. The number is that 2x minus 1 that's written in parentheses, and the exponent is 2. So I'm going to switch that to the exponential form, B-E-N, Ben, for base exponent number. So again, the base is 3. The exponent is 2, then equals, then the number is 2x minus 1. So let me simplify the 3 to the second a little bit. 3 to the second is 9, right? 3 times 3 is 9. So 9 equals 2x minus 1. So you have to solve that equation. That's not that big a deal. The 2x minus 1 on the right, I want to pull the minus 1 over to the left side, combine it with the 9. When it goes to the left, it'll become a positive 1. 9 plus 1 more, I have 10, equals 2x. And now if you divide out the 2, 10 over 2 is x, and that reduces nicely to 5. So with some algebra that's not too bad, we can see that x is 5. It's not nearly as bad as it looked.